Hello everyone. Welcome back to the lecture series of ICSE 10th Chemistry, Mole Concept. This is our fifth video of Mole Concept. In the first video, we have covered the sums based on Gay Lussac's law. In the second and third video, we have done the sums based on Avogadro's law. In the fourth video, we have done percentage composition. And in today's video, we are going to cover the sums from empirical formula and molecular formula. My name is 𝐷𝐥𝐞𝐚𝐬𝑑𝑻 and you are watching 𝐷𝐴 classes. Let's get started. The first question is, a compound gave the following data: carbon is 57.82%, oxygen is 38.58%, and rest of the percentage is hydrogen. Its vapor density is 83. We have to find out the empirical formula and molecular formula. So we all know that while doing this sum, we have to first draw a table. So let us draw the table. So in the table, the first column, we will write element, what all elements are there. In the second column, percentage. In the third column, we are going to write the atomic weights. In the fourth column, relative number of atoms, and in the fifth column we are going to write simple ratio. Okay, now let us fill this table. We have elements carbon, oxygen and hydrogen. So under element we are going to write carbon, hydrogen and oxygen. The percentages are given. So carbon is 57.82%. Hydrogen we do not know, oxygen is 38.58%. Hydrogen we will just do 100 minus the addition of these two. Atomic weight of carbon is 12, oxygen is 16 and hydrogen is 1. And the vapor density of this compound is given 83. We have to find out the molecular formula and the empirical formula. I am just rubbing the question now so that we have enough space. So first of all, we are going to find out the percentage of hydrogen. So if I do this way, 57.82 is your carbon and oxygen is 38.58. So that is coming up to 96.140. So hydrogen will be 3.60. So hydrogen is here 3.60. We got the percentage of hydrogen. Now to find out the relative number of atoms, we have to divide the percentage by the atomic weight of the corresponding element. So here we are going to do 57.82 divided by 12. Here it is 3.60 divided by 1, that comes 3.60. And here it is 38.58 divided by 60. So we need to do the division over here. We'll do the calculation little faster. So here it comes 4.8. This is 3.60 and this is coming 2.41. I'm not doing the calculation. You can do the calculation on your own, 2.41. Now, to find out the simple ratio, we have to divide this by the smallest number. Now, we can see here it is 4.8, here it is 3.60 and here it is 2.41. So, 2.41 is the smallest number. So, we'll divide all this by 2.41. So, it will be 4.8 upon 2.41. It almost comes to, you can understand. This is 3.60 upon 2.41. And this is 2.41 upon 2.41. So this is coming 1. Now 3.60 upon 2.41 is 3 by 2. If you divide it by 12, we can understand it is 2.4 and 3.6. It is divisible by 12. 12 3s are 36 and 12 2s are 24. 3 by 2 and that is giving you 1.5. So when we get the ratio as this 1.5 or something, then we have to make one more column because this is not the whole number. So one more column we have to make over here and that is the simplest ratio. And in this case, what we are going to do is, we will multiply all of this by 2 to get the whole number. So this will be 2 into 2, 4. This will be 1.5 into 2, 3. And this will be 1 into 2, that is 2. So now we got the smallest or simplest whole number for all the elements. Therefore, now we can get the empirical formula. So the empirical formula will be C4, H3 and O2. This is the empirical formula. Now we need to find out the molecular formula. So for that, we need N. N is an integer. And what is N? N is equal to molecular weight divided by empirical formula weight. Empirical formula weight. So molecular weight is again 2 into vapor density. So 2 into vapor density divided by empirical formula weight, which is, we can understand here, from here we can get it actually 4 into 12. So I am doing it here, 4 into 12 plus 3 into 1 plus 2 into 16. So it is 2 into 16. So it's coming 2 into vapor density is given 83 divided by 12 into 4, that is 48 plus 3 plus 32. So let us see what is it. 2 into 83 divided by 48 plus 32 plus 3. 48 plus 32 plus 3. 83. This is also coming 83. So 83 gets cancelled. N is equal to 2. Now when we have N is equal to 2, I'll just rub the, okay, I'll write it here. So the molecular formula is equal to N into empirical formula. So N we got 2, so we'll write it 2 into empirical formula is C4 H3O2. So finally the molecular formula is coming C8, 4 2s are 8, C8 H6O4. So this is the molecular formula. Let us start the second question now. The second question is 4 gram of metallic chloride contains 1.89 gram of the metal X. There is a metallic chloride where metal is 1.89 gram and total sample weighs 4 gram. Calculate the empirical formula of the metallic chloride. Atomic weights of the metal and the chlorine is given to you. So here, total metallic chloride, weight of metallic chloride is given 4 gram. It contains 1.89 gram of the metal. So weight of metal X 4 is 1.89 gram. 1.89 gram. So this is metallic chloride where metal is 1.89 gram. So rest of the weight will be of chlorine. So weight of chlorine is 4 minus 1.89, which will come 2.11 gram. So now here the percentage is not given, weights are given. So in the table, instead of percentage, I have written composition. So here what are the elements? One is your metal X and the other one is chlorine. Metal X composition is 1.89 and chlorine's composition is 2.11. Atomic weight of the metal which is given 64 and chlorine is 35.5. Rest of the part is same. So relative number of atoms will do 1.89 divided by 64. So if we do this calculation, it is coming 0.03 and here it is 2.11 upon 35.5 and this is given 0.06. 0.06. Now again among these two numbers 0.03 is smaller. So we'll divide 0.03 by 0.03 which is 1 and 0.06 by 0.03 which is 2. So we got the simple whole number ratio. Therefore, the empirical formula will be X1 and Cl2. 1 is silent, so we can write XCl2. This is the empirical formula of this metallic chloride. Let's start with the next sum. Question number 3. Calculate the molecular formula of a compound whose empirical formula is CH2O and vapor density is 30. So the empirical formula is given. Empirical formula, which is CH2O, and the vapor density is given, which is 30. So here we need to find out N. N is an integer, and how to find out N? N is molecular weight divided by empirical formula weight. Empirical formula weight. Now, again, molecular weight is what? Molecular weight is 2 into vapor density, which is given to us. And empirical formula weight we can find out from this formula. It is atomic weight of carbon plus atomic weight of 2 hydrogen plus atomic weight of oxygen. Now, 2 into vapor density is 30 over here, and atomic weight of carbon, which is 12, plus 2 into atomic weight of hydrogen, which is 1, plus oxygen is 16. So it is coming 2 into 30 divided by 12 plus 16, that is 28. 28 plus 2 is again 30. So 30 gets cancelled. N is 2. So the molecular formula is N into empirical formula. N has come 2, so we'll put 2 over here, and empirical formula is CH2O. So the molecular formula comes C2, H2 into 2 is 4, H4 and O2. Therefore, the molecular formula is C2H4O2. Question number 4 in front of you. It says a compound has a following percentage composition. Aluminium is 0.2675 gram, phosphorus is 0.3505 gram, oxygen is 0.8682 gram. If the molecular weight of the compound is 122 and its original weight on analysis gave the above results 1.30 gram, calculate the empirical formula of the compound. Now let us see. Molecular weight is given, so we can also find out the molecular formula also from here. Empirical formula they are asking, we can also find out molecular formula. Let us make the table. Here we'll write element. Since the percentages are not given, we'll write composition because here the weights are given. Next will be atomic weight. Next column will be relative number of atoms. Relative number of atoms. And last column will be simple ratio. Okay. Now, what are the elements over here? One is your aluminium, phosphorus and oxygen. These are the 3 elements. Aluminium is how much? 0.2675. Phosphorus is 0.3505 and oxygen is 0.682. Atomic weights, the atomic weight of aluminium is 27. Phosphorus 31 and oxygen is 16. Now we have to find out the relative number of atoms. So the weight, that is 0.2675 divided by 27. Here it is 0.3505 divided by 31 and it is 0.682 divided by 16. Let us see how much it is coming. We can just put it in a bigger column. Okay. So this is coming 0.0099. 0.0099 it is. The next one is 0.0113. 0.0113 and the next one is 0.0426. 0.0426. So here the lowest value is 0.0099. So here simple ratio will write 0.0099 upon 0.0099, which is 1. Okay. Now the next one is 0.0113 divided by 0.0099. This comes 1.14. We'll round it off to 1 only. 1.14 can be rounded off. And here it is 0.0426 by 0.0099, which is coming 4.3. This comes 4.3, which is again rounded off to 4. So the ratio, the simple whole ratio comes like this. This is not simple ratio, this is a whole number ratio. This is whole number ratio. That comes like 114. Therefore, we can find out the empirical formula from here. The empirical formula is Al1, P1 and O4. So that is AlPO4. This is the empirical formula. Now the molecular weight is given. The molecular weight is 122. So we'll find out N. N is what? N is molecular weight upon empirical formula weight. So molecular weight is 122 and empirical formula weight is the weight of aluminium plus weight of phosphorus plus 4 into weight of oxygen. So let us put the values. Aluminium is 27, phosphorus is 31 plus 4 into 16. That comes 27 plus 31 and 4 into 16 is 64. So that is also 122. So this is coming 1. This is coming 1. N is coming 1. Therefore molecular formula is equal to N into empirical formula. That is 1 into empirical formula AlPO4. So finally the molecular formula is AlPO4. Let us proceed to the next question. Question number 5. A hydrocarbon contains 82.8% carbon. Find the molecular formula if its vapor density is 29. Since the compound is a hydrocarbon, we can understand that the compound is made up of only carbon and hydrogen. So in the column of elements, we are going to write the first element is carbon and the second element is hydrogen. Second column will be percentage, where the percentage of carbon is given, that is 82.8%. Hydrogen percentage we can find out by subtracting it from 100, and the percentage of hydrogen is coming 17.2. We can just do the calculation. Okay, next is atomic weight. So atomic weight of carbon is 12 and hydrogen is 1. Next will be relative number of atoms, and the last column will be simple ratio. Now let us find out this. Okay, so in the relative number of atoms, we'll do 82.8 divided by 12, and here it is 17.2 divided by 1, which will give you 17.2 only. 82.8 divided by 12 will give you 6.9. So now among these two, 6.9 is a smaller value, so we'll divide by 6.9. 6.9 upon 6.9 is 1. 17.2 upon 6.9, it will give you 2.5. Now when we get 2.5 like this, then we have to do one more column where we are going to write down simplest whole number ratio. Since we cannot round it off, it is 2.5, so we have to multiply both the numbers by 2. Okay, in simplest whole number ratio. So 1 into 2 is 2 and 2.5 into 2 is 5. Therefore, the empirical formula will be C2H5. This is a empirical formula. Now the vapor density is given, so from here we will find out N. N is equal to molecular weight upon empirical formula weight. And molecular weight is equal to 2 into vapor density divided by empirical formula weight we will get from the formula, that is 2 into atomic weight of carbon plus 5 into atomic weight of hydrogen. This is 2 into, the vapor density is given 29. Here it is 2 into 12 plus 5 into 1. So that's 2 into 29 divided by 25 plus 5. That is 2 into 29 upon 29, which gets cancelled. N is equal to 2. Therefore, molecular formula will be N into empirical formula. N is 2 and empirical formula is C2H5. So that gives you C4H10. So the molecular formula of this compound is C4H10. So in today's video, we have covered 5 questions on empirical formula and molecular formula. I'll come up with another video. In the next video, we are going to cover some more questions, maybe another 5-7 questions we'll cover from the same topic. And then we will move on to the next topic, that is chemical reactions. So stay tuned and thank you so much.